Hi, this is the BNS Chapter 14, Segment 3 outline. We're going to get started with a type of informal sleep deprivation experiments that we all are unaware that we're always doing. The thing is, we are always aware when we don't get enough sleep because we get sleepy. We use sleep deprivation to discover mechanisms of sleeping and waking. Sleep recovery is very important in this. More than normal sleep. It's when we get more than normal sleep after being sleep deprived. It depends on whether it's partial or complete. It only partially recovers us from our sleep debt or completely. Um, Effects of sleep deprivation depends on personality and age. However, there's never been any actual situations really of experiencing hallucinations from extreme sleep deprivation. Even people with schizophrenia don't. The most common behavior changes from sleep deprivation are irritability, difficulty concentrating, and episodes of disorientation. When someone is mildly sleep deprived, like they've only gotten around maybe 4 to 6 hours for 2 weeks, they usually will falter, start working normally again, and then falter again. People with moderate sleep deprivation aren't sleepy, but perform have poor performance, and could have same and people even with moderate sleep deprivation could have the same cognitive deficits of people who haven't slept for 3 whole days. This sleep deprivation is pretty prominent in airline employees because they don't get to adapt to the different time zones and have deficits in cognitive tasks, and including reduced volume of the temporal lobe. So, probably it would be beneficial for them to be able to recover from jet lag in order to restore their circadian rhythm. In flies, so this is an example of how we're genetically prone to like different types of sleeping. Mutation of the cycle gene causes flies to die after 10 hours of sleep deprivation. An experiment was done on Randy Gardner, who went 11 days without sleep. In his first night of sleep recovery, he had the greatest amount of stage 3 sleep, but at the expense of stage 2. And no matter how much sleep he had in the first night, he did not make up the sleep debt he received. Rapid eye movement shows the greatest recovery on the second day of sleep recovery, and there's greater intensity of rapid eye movement, in which there's a greater number of rapid eye movements per the time period than what is normal rapid eye movement when sleeping. There's 4 functions of sleep that are caused by sleep: energy conservation, niche adaptation, body restoration, and memory consolidation. Getting started on energy conservation, we use less energy asleep than awake, and this is due to diminished metabolic activity. It's probably why some animals hibernate in the winter. It's to use less energy. We use and in experiments, we use small animals because they have high metabolic rates. And they usually will go to sleep a lot because can reduce activity when food is scarce in order to reduce their metabolic rates. There's a high correlation between total sleep per day and waking metabolic rate. Small animals need to sleep more than large plant eaters because they need to use so much more energy just to maintain their body heat. And on the opposite end, predator species don't apply to this because they can sleep more than prey. However, in zoos where they don't need to worry about catching food or being prey, herbivores still need to spend more time eating than omnivores and carnivores because they Omnivores and carnivores eat more high-calorie meat. So there's two types of niche adaptation involved with sleeping, which is whether animals are nocturnal or diurnal. Nocturnal, of course, is being awake at night and asleep during the day, and diurnal is being awake during the day and asleep at night. And it is part of each species' ecological niche, and this is due to the fact that each species is better at gathering food at night or the day, and also avoiding predators at night if they are not carnivores. And this allows each animal to conform to an ecological niche. For some animals, however, it can actually be beneficial to not sleep. For example, the male pectoral sandpiper. The males compete for mates by not sleeping, and the one who sleeps the less gets to mate the most and produce the most offspring. Sleep is used to rebuild materials lost while being awake. Most growth hormone is released during the stage 3 sleep, SWS. Exercise can help somebody fall asleep more quickly, but however, they won't sleep for longer. Mild sleep deprivation causes more pain the following day. For example, when a nurse is waking someone up to take vitals, when the next day they might feel more pain getting a needle than they did before. People who sleep less than 6 hours a day are more likely to die the next year. This also applies actually to people who sleep more than 8 hours on average a day. And then people who sleep less than 5 hours a day are more likely to develop diabetes. And people who work at night and sleep during the day are actually more likely to develop cancer. So there's actually a lot of links to how we sleep affects our physical health. Sleep allows the brain to get rid of waste. For example, glia control the flow of cerebral spinal fluid through brain channels, and it flows faster while asleep than awake. And this occurs for the B amyloid hormone, which is also linked to Alzheimer's. We cannot learn new material while sleeping because rapid eye movement won't let you obtain new information that's not important. However, Jenkins and Dallenbach did a study that proved that sleep aids in the consolidation of memory of tasks that were performed before you went to sleep. NREM aids the consolidation of memory, especially declarative. Declarative memory is a memory that can be stated or described. Slow voltage oscillations during NREM actually help with remembering declarative memory more. Rapid eye movement helps with non-declarative memory, which is just basic like tasks or like color memorization. Exposure to familiar odor during NREM also helped with the consolidation of declarative memory. If somebody was doing a task and was left in odor, if the person went to sleep, they would actually remember the task better. However, the odor did not work for rapid eye movement. Memory consolidation function may involve determining synapses gained or lost during sleep. In mice, mice formed new dendritic spines on neurons in the motor cortex, and sleep deprivation reduced the amount of new spines created. However, allowing the mice to sleep increased the spines. William Dement is a person who slept only 3 to 4 hours a night for 50 years and died at the age of 80. So he's an example of how, despite all the information we heard before about how lack of sleep can cause so many physical and mental health problems, he's an example of how he was able to live a long life while only sleeping 3 to 4 hours a night. Ray Metis observed a 70-year-old nurse who only slept 1 hour a night, and she lived until her mid-70s. During her sleep, she was able to get to stage 3 sleep and rapid eye movement. However, she had less of stages 1 and 2 sleep, and this is evidence that she might actually just been a very efficient sleeper because she never felt drowsy throughout the day and was still very high functioning and not unhealthy. So the active state is is mediated by at least 4 interacting neural systems. The forebrain system, which displays SWS, the brainstem system, which activates forebrain to wake, the pontine system, which triggers rapid eye movement, and the hypothalamic, which affects the other 3 systems to determine whether the brain will be awake or asleep. Manipulating people to go to sleep during surgery is done through general anesthetics, which can include either barbiturates or gas anesthetics. It makes the person unconscious, and there's evidence that anesthetics produce slow waves similar to the waves that occur during SWS. This is evidence that anesthetics tap into existing brain networks to prompt sleep. Some general anesthetics are glutamate antagonists and therefore block neuronal excitation. However, most are non-competitive GABA agonists. Frederick Bremer developed a type of preparation of transecting the brain into upper and lower parts. An incision between the medulla and the spinal cord resulted in what is called an isolated brain. And it found that the system promoting SWS was forebrain through this. And animals that had their incision put in the medulla alternated between wakefulness, SWS, and rapid eye movement. However, if the transection was made at the midbrain instead, which is known as an isolated forebrain, those animals experienced constant SWS and no rapid eye movement.